All right. Hey guys, how's it going? So today I'm going to be doing a bit of a follow-up to the previous video where we get hands-on with Jac'd, with the Jac'd ecosystem, and we'll tinker a bit and we'll create some stuff, we'll run some stuff, and I'll leave you with a little bit of a homework assignment or a little bit of a to-do, just to get your hands a little dirty so you can play with it. Now, this is really for the developers that would be using this to supercharge their creation of software in today's era. Of course, I'll do another video for contributors just so you can understand the implementation and the code base, which is going to be super fun. So watch out for that one coming soon. But let's just jump right in. I got a virtual environment set up. I'm switching to it now. So this is the virtual environment for the, this is just a clean Ubuntu install. So we're gonna start, I'm gonna pretend I'm a new dev. I just got Ubuntu, got my VS Code extension installed. And so now we're just gonna get things set up and then make sure everything's working. So I'm gonna open my VS Code, my very well-loved IDE here. That's probably the world's most popular IDE. So the first thing you're going to want to do is install the Jac'd extension. Of course, you need extensions in order to make all of the tools awesome, syntax highlighting, some type checking, etc. Remember, the type checker is a work in progress, and it's going super duper well, inspired by the architecture of Pyrite. But you'll want these tools, auto formatter, all that goodness, right? So the first thing you do is you go to extensions. And now if you're using VS Code, you can just type Jac'd and it'll pop up. It's in the marketplace. So if you know Microsoft and their interesting choice that they made of making it so that their marketplace is only for the official Microsoft VS Code, which is kind of a lame move if you ask me. They should open it up to things like Cursor and the other forks, Codium and some of the other forks of if you want a good open source ecosystem, you have to pick, right? Either you're going to do it or not. Anyway, so long story short, Microsoft doesn't let other forks of VS Code use the marketplace like Cursor. So we have instructions on installation. On the installation page of the documentation, I'll just show you that real quick. So by the time you see this video, we're going to have instructions. Of course, this is currently the instructions on how to get it through the marketplace, but we're going to add instructions for, just installing it in Cursor or anything. And so that'll be up by the time you see this video. So you can check that out if you're using, Cursor, let's say. And also, we're also putting, their Cursor does have access to a marketplace. We're also submitting a release there too. So we're going to get it in all of the nice places. So everything's easy for you guys. But okay, so we've got that installed. So the first thing you want to do in a fresh install of Ubuntu is, well, you get your terminal up because that's how we roll. Well, I'm a very terminal type of dude. And so let me make a directory. Since we're gonna write some code, let's call it code. Okay, and then first you're gonna want to pip install Jac'd. Now, of course, if you do pip install Jac'd, since this is a fresh install of Ubuntu, this won't work if you try this, right? And it doesn't work because you need to install pip. I mean, Ubuntu comes with Python 3 native, but you need to install pip and you need to install the virtual environment. So let's do that real quick. Sudo app install, yeah, Python 3 pip and Python 3 venv, right? And so we're gonna let that install, handy dandy password that's not secure, and then yes. Okay, so that's gonna install. Let's give it a minute. All right, so that's going, almost there. Okay, cool. So we're all installed. So we have our virtual environment. Now, virtual environments are really important, right? If you don't have a lot of experience with working with Python, you should go get some of that experience. No, I'm just kidding. If you don't have a lot of experience with Python, you know that typically you have to have a virtual environment. I like venv because it's very clean and minimal. You can also use conda, of course. If you already know how to use conda, you probably don't need me to walk you through it. But you set up that environment because dependencies are a hot mess. You know, so you always want a different environment for various projects you might want to work on because of package dependencies, which is a classic challenge in every ecosystem. Anyway, so let's get that installed. Pip install. No, yeah, we have pip. No, I got to set up the virtual environment first. So it's Python 3-m venv. And all of this is super standard stuff that you can just go online and just Google, like, set up my Python environment with venv. And there'll be tons of instructions of that. So the first thing you do is you need to activate that virtual environment, which is, what did I call it? Env. And then bin, and then activate. Very standard. Okay, so now we're in our own Python environment, and that environment is called env. So now we can do our pip installs, right? So as I mentioned in the prior video, it's very clean, pip install Jac'd. And so that'll install. There actually are no dependencies, but this particular release, there was a languishing MyPy in there, so it installs MyPy too. But by the time you play with this, you won't even have this MyPy dependency. Okay, everything's good. So we now have Jac'd. Okay, great. So we have an extension. We have Jac'd. Let's go to our code directory, and let's start with our first, like, hello world style Jac'd program, just to make sure everything's working. So I'm going to create a file called first.jac'd, and then I'm going to open it. And there's many ways you can open it, of course. Like, you could use this thingy. Oh, open. You could use a file explorer. Oh, so something just happened there. So it's good to pay attention to this, right? So what happened is, once I opened this file first.jac'd, there's a environment selector, so you can select what environment of Jac'd you want, that pops up here. So I clicked away, and so currently it looks like this. So it looks like there's an error, but it's not really an error. You just haven't associated your Jac'd with the extension. And one of the beautiful things about how we architected Jac'd is there's a language service, there's the official language service server provider that's built into just that Jac'd. So you get the compiler, you get the runtime I talked about, you also get an LSP, of course, just so you'll have everything in one nice bundle. So you just have to point your extension to Jac'd, and then that'll do it. Now, how you can bring that up again, if you see an error, or it'll probably tell you, because we're going to make this look better by the time you see this video, you can click this button here, and it'll give you the selector again. And so to associate it, the selector will detect your Jac'd, your Jac'd environments where you have Jac'd. And so you can just pick the Jac'd in the environment you want. It'll do this little reload, and then you should see a beautiful LSP has started. There we go. Jac'd language server has started. So sweet. We're on our way. So that means we'll get syntax highlighting and all that goodness. So we can just let's do a simple Jac'd program. Let's call it love Jac'd. Let's create a function called love Jac'd. And what this function is going to do is return a string. And what's that string going to say? Let's say Jac'd with Jac'd, Python becomes even more awesome. Okay, cool. So that's good. Let's put our semicolon. Now, one thing you'll notice is the syntax is a little different. It's like you feel like you're implementing in pretty much 90% of other languages with the curly braces, but you have the familiar Python syntax, right? So we have the curly braces and semicolon because this really homogenizes the language with what we believe is better readability. There's actually a number of little tweaks made to produce a better kind of syntax. And this one's the most maybe inconsequential tweak, but most of the keywords, like all of the keywords, are the same as Python, and you can express anything in that Pythonic way. You'll get to see more of the interesting improvements that we've made from a syntax sugar standpoint. But remember, as I'm going to show you in about 2 minutes, you can mix and match your Python with your Jac'd in as much as you'd like. So where am I? Oh, okay. So another one of these changes is this with entry block. Now, one thing about Python's history is it started as a scripting language. So it's essentially like a replacement for things like bash and so forth. And so you can kind of throw statements anywhere. However, when you throw statements willy-nilly around your module or willy-nilly in the body of your classes, you ultimately end up having unmaintainable code if you do that a lot. So we wanted to make it very explicit when you're not creating a function or a class or something that is kind of more rigorously type checkable, or kind of more structured. And if you're putting random statements in your program, we want that explicit expression of that, right? And so this is very important for scalable programs. If you actually have on an import module random code running, that gets to weird issues that might take a lot of work to find later. So this is good for hygiene. And so we do this, right? So print, let's see. Let's just print our love Jack just to get this example going. All right, let's see. Let's make sure that this is a proper F string with our standard. So F strings work exactly as you would expect. Pretty much, if I don't talk about it, just assume it works exactly like it does in Python. Okay, so let's just run this, make sure everything's running. So Jack first.Jack. Okay, cool. That worked. Now that's interesting. So everything's set up, everything's working. That's our first simple hello world style example, but with a function, because functions are cool. All right, so let's see how we can also take a different approach, right? So let's say you wanted to start with Python and then just use Jack where you need it, or just mix some Jack modules in. One thing I emphasize in that video is, at the end of the day, this is a transpiler, much like TypeScript transpiles to JavaScript. There's a transpilation kind of DNA in the methodology of compilation. And so you can mix and match your modules, right? And so if I wanted to say touch mypyfile.py, right? This is a py file, right? Let's open it. mypyfile.py, and that'll open. No, not open. I meant code. Let's code it. So that did, oh, Jesus. Oh my gosh. Oh, what, does home not work properly? Okay, I'm just silly. My muscle memory is a little weak. I've been writing too much and not coding enough. Okay, so let's see. So what I want to do here is, if you import Jac'd to any Python file, right? You can just naturally then import any module that's expressed in Jack. And we have one such module. We have first.jack in this folder. So if we import first, and let's just do a from first import, what did we call it? Love Jack. So this is standard Python, and then let's say we print Python is awesome. But, and then we put our handy dandy love Jack in here. Then we actually make it a F string so that it's reasonable. When we Python 3 that, right? So our standard Python, mypy file, awesome. Wait, what happened here? Oh, keynote. So with entry, this is exactly what I was talking about, right? So when we import, let's say we just want the love Jack function, but in this module, we actually have some code, like just hanging out in the module. When we import that module, that code's gonna execute on the import. Standard Python behavior, right? Now, what you normally have to do is this wonky if name equals underscore main, so that doesn't happen. The syntax for that is a little bit cleaner here. You could just say with entry main. And then with this modification, we should not see two prints of the with Jack Python becomes more awesome. So I'm going to run this again with that tweak, and beautiful. Python is awesome, but with Jack, Python becomes more awesome. And what I want to point out here is this is an example of us in pure Python mixing in a Jack module. And so the beautiful use case here is if you wanted to say use the by keyword, which is one of the biggest innovations that we're releasing to the world with. Top tier paper published about it, and it's real. It works for real applications. you can actually just have your agentic AI thing that uses the by keyword in one module and mix it in to your existing Python code if you'd like. So all right, so this is a cool little coding example. Now we know everything's working. You can do this at home, of course. But I promised I was going to leave you guys with a little bit of an assignment, right? And let's do that now. I'm trying to think if there's anything I forgot to talk about that I wanted to talk about. I think this is good to get you started. Video's already pretty long, so let's just wrap things up with a little assignment. Now the assignment is, based on this setup, right? Let's say you have this is all working for you. You've been able to run through this nice example. What you can do next is, if you go to the official documentation, and this is at jaclang.org. Of course, you can get there from going to Jac'd first. So if you wanted to go to jac'd.org, we've got this page. This is continuously evolving. It's getting even more cool. You should see the new prototype. Anyway, we have this page. Of course, if you click Getting Started, it'll take you over to the Jac'd documentation. And then there's this Learn Jack in 5 minutes. Now, this is really, really cool because it kind of gives you the quickest tour possible through what the syntax feels like, what the language feels like, and it shows you some cool features that you can engage and access. So you can look at this. There's a very simple Python game in pure Python. And then we show you, that's step 0. It's like, okay, Python game. This is the guessing game, very standard example used to teach programming, where you guess a number, and then if the number's right, it's like, congrats, you guessed it in 10 turns. And then we show we show the most Pythonic articulation of the same code in Jac'd. And so if you look at these two versions of the program, they look very similar, except you see some curly braces. Init's a keyword. And so you can just use init. Python sees this as underscore, underscore, init, underscore, underscore. There's only a few of these kind of keywords, like self and init become keywords in Python, even though they're treated as names. For the compiler people, you guys will know exactly what I'm talking about. And everything is annotated, right? Because we definitely care about type safety at first in this kind of view of what a Jack Python should look like. And so everything is a type annotated, much like TypeScript. But other than that, the syntax is almost exactly the same, right? So, but then there's some nice changes that we go into in step 2 that makes things better, in our opinion, all the way up to step 3. Now, step 3 shows a very, what I call, Jactastic version of the same Python program, where we have a separation between the implementations of the functions and the implementations of the class interfaces. It turns out that when you're reading Python code of a sophisticated code base, it's pretty much all unreadable without tools, because the implementations and the interfaces to your classes are shown to you at the same time in what would be regarded by many as very difficult to process what's going on. So, and it turns out that most developers read code 90% of the time and write code 10% of the time. That's like a number from literature. I can't remember the exact paper, but we spend most of our time reading code. And this one thing that's beautiful about the C include ecosystem is that reading the interfaces of your program, your classes, and the objects that you should be using is very, very clean. So we achieve that in this most Jactastic version of the same program. Now, then there's step 4 that introduces object spatial programming as a concept. That becomes very important later. But step 5 and step 6 is where the assignment comes in, right? In step 5, we show you the same program, but written in a way that it becomes a service that can run in a cloud. And so the beauty is that there's pretty much no code changes. Actually, I think there's actually no code changes. We just do this with entry main, as I showed you before, so that you can actually run, if you run locally, it'll actually work. and you can also run it as a service in the cloud. And so it's certainly something to try at home as part of this assignment. And then step 6 is where you add AI. And we use the Gemini because the keys are free. You can get a free key from Google to use this Gemini model. But this shows you how you can use the by keyword to get accuracy, incredible accuracy from your LLM without using prompt engineering, which is a very, very significant contribution of the Jac'd ecosystem. Is we take prompt engineering and we turn it into a compiler runtime problem, which is actually a cutting edge way to view building sophisticated AI systems. Now that sounds like magic, but you'll have to dig deeper to kind of fully understand it. Indeed, there's a byllm.ai website that's a great introduction to this tech, and this is a website on that one category of feature for AI integrated software that we think really needs its own intellectual treatise through a research paper and MTP, meaning typed programming. So this is the research paper here. It's going to be presented at OOPSLA in a month, and so you can read this paper to understand the science behind this innovation, and then this is the plugin to Jac'd that allows you to take advantage of that innovation to build next generation AI. So getting 5 to work and 6 to work is the first part of the assignment on your own, and then you should build something that's different than 5 or 6. It can be small, it could be a calculator, it could be a tool, to-do list, whatever you want to build. Build something that's not the guess game, that takes advantage of 5 and 6, steps 5 and 6. And so that's essentially what you can do at home to kind of get started, right? All right. So with that, I think that's a little bit of hands-on, first 20 minutes with this ecosystem. Try it at home. Have fun, and happy coding. Yeah. Peace.